Welcome, welcome. This is time for the seminar Arcade Game Port to ZX Spectrum, a reverse engineering thing that I couldn't fully read. Reverse engineering...
A game.
Work? Something?
Port for the ZX Spectrum. Yep.
It's working? Your microphone? Good.
I think so.
So this is Rui Martins, which is a veteran on the ZX Spectrum. He has coded several ZX Spectrum games, ported a few of them from the arcades, and is going to tell us all about the limitations of doing that work. It's a very fascinating talk. He has gave a version of this talk before, and I think you guys will love it, and also on the stream. So yeah, please enjoy, and yeah, I'll leave you with Rui.
Thank you. Okay, so my talk is just about what are the challenges when we start to think about porting a game into the ZX Spectrum. So the first things that we'll see is that we have a bunch of topics to talk about. I won't go through all of those or read them. You'll see while we go through. So when you're trying to do a port, the first thing we usually do is define our target platform. In this case, I chose Spectrum 48K because that's what I love to code for. Then you select some game that you want to actually port the game to. In this case, Magical Drop 2 from the arcades was actually from the Neo Geo was one of the games I wanted to port. And I chose specifically a source which is our origin, which was from the Neo Geo specifically. And the first or the fourth thing that you need to do is make sure that it's feasible to actually do the port because the machine might not be powerful enough to do it. So, first thing we need to know is our platform. So, what are the limitations that we actually know from actually using the platform so that we know if, or we have an idea of what's the actual abilities that we can explore to actually do the port successfully. So we need to actually try and make some changes or games or samples, a bit of code so that we can know the limitations experimentally and not actually just theoretically, okay? Because theory is very different from practice. So we develop a game, and after developing the first game, we should develop another game before we actually try a port. Why is that? Because we learn valuable lessons with the first development that we can apply in the second that will give us even more insight on the platform. So the first thing after you have some knowledge about the platform is to know your game. What do I mean by know your game? You need to be able to play it, to know how to play it. You need able to get a feel for the game. So is it a fast game? Is it a slow game? Is it a puzzle game? It's a shooting game? What kind of game it is? And most importantly, you need to watch others play because you usually have your own voices playing and you won't see specific features of the game that you will eventually see when others are playing the game. So watch others play too. And play with others also, because it's important to know how the other players react, and you will see your moves, and you will see different things in the game that you probably haven't seen before. Okay, so what is game essence? How well do we know a game? Probably all of you know what this game is, right? But I bet that most of you will not know what's the behavior of each ghost and what's the name of each ghost. So you probably don't know this game as well as you thought you knew, right? So you need to study the game. Tetris is another game that everyone knows, but do you really know Tetris? How many parts of the long columns do you actually get? What is the percentage? What is the distribution of parts, the different parts in a game? Does it change when we are playing, when we are doing many lines or not? So you need to study the game in more depth. The same happens, for example, on a game like Puzzle Bobble. How does it evolve? Does the patterns change? Does the two-player games change some of the behaviors of the game? So we really need to study the game. Anyone knows what this game is? R-Type, exactly. So this is the boss of the first level. And to pass the boss of the first level, there are several quirks, and those quirks depend on each of the origin platforms that you look at. Not all ports are the same, because not all ports, unfortunately, derived from source. They are re-implementations of the original one or already a copy. Okay, so make sure you know the quirks from what your origin is. Okay. So, what is the essence of Magical Drop 2, which is the game that I chose? And now I'm going to show you a quick video. And I'm going to show you a play of Magical Drop, just a two-level play. Okay, so this is a simple person or not a very experienced person playing this game. Now I'm going to show you someone actually playing this more or less quickly. This is on an actual arcade. This is the CPU on the right side, and on the left side is the human player. And as you can see, it's very easy, if you know how to play, to crush the other player quickly. Okay, so what this implies that this game is extremely fast to play. I'll let you see another small level. So this is in battle mode, where you're playing against another player. This is also as single player mode. To the ones with a quick eye, you probably saw that there are attack patterns, and that we actually are able to push lines to the adversary. Okay? So let's get back to the presentation. So, sorry. If I would ask what is the essence of Magical Drop in terms of gameplay in this case? Anyone? So it's a match 3 game, right? We match 3 or more of the same color and it pops. And besides that, is an extremely fast game if you know how to play it, right? That's the basic essence of Magical Drop 2. So what are we up against? The challenge is basically we have the Neo Geo hardware, which has a lot of really large chips, against ZX Spectrum 48K, which has just a dedicated chip in itself, which is the ULA and the CPU. And then the Neo Geo still has cartridges with extra memory and ROM and all that. So it's a tough challenge. And just to have an idea of the details of the specs between one and the other, we can actually see that the Neo Geo actually uses a Z80 CPU faster than the Spectrum just for the sound. Okay, so, and has a lot more colors and has a slightly bigger video display that will give us some trouble to fit the game after it. So we won't dismay, and let's go and see what are the challenges. So this is the board of the Spectrum, and we'll detail this in parts. So we first have the PAL video encoder, which is the chip that actually generates the image physically. Then we have the crystals for the PAL color carrier on top, and the crystal for the actual ULA clock, which is 14 megahertz, then is later divided by 4, which gives us the clock for the CPU, which is 3.5 megahertz. And then we have high RAM, which is MEM that is exclusive to the CPU, so not able to be accessed by the ULA, so there is no contention. And then we have part of the memory that is the video or lower RAM that is actually shared between the CPU and the ULA, so it's where the CPU actually builds the images to generate that are generated by the ULA and the pulse system to the video display. So this obviously has contention, and the CPU will be slowed down if we are accessing the video memory when the ULA is actually trying to draw on screen. So we will be really slow like that guy if we are actually accessing the screen when the ULA is also accessing. So we have to account for this if you want speed. So what can we do in a full frame? So this is a Spectrum screen. It's 256 pixels wide and 192 pixels high. So we have 6,144 bytes of data. And we have a color buffer because we only have 2 colors for each 8 by 8 pixels. That is 768 bytes. And this gives us that total of 6,912. We know the PAL refresh rate on a Spectrum, which is European, it's 50 Hertz. That means we have 20 milliseconds per frame. So 20 milliseconds divided by the clock frequency, we have about 70,000 ticks or clocks per frame. So we also know that the fastest Z8 instruction, which is like move data from one register to another, it's only 4 clocks or 4 ticks. But that's the fastest one. There are instructions as slow as 13 clocks. The most specialized instruction for copy is LDI that takes 16 clock cycles to copy a single byte. So if we divide these 70,000 ticks by 16, worst case, we will get a little bit over 4,000 instructions. And if we actually look at the fastest way to push stuff into memory, it's actually using the stack with pop and push instructions that will allow us to copy 2 bytes. We get about 3,000 and something instructions per clock cycle. Sorry, per frame. What this means is that we don't have enough time to fill the entire screen every frame. So forget that idea that we use on PC. So I have a new frame, I will build everything from scratch and then present it on screen. That doesn't work, okay? So you need to keep it low and avoid updating as little as possible, okay? So what are our screen update options? The obvious one is we need to reduce screen area. So if we pre-draw something and then only draw a part of the screen, we'll get for sure some bandwidth saving on the CPU. The other thing we can do is partial updates. Partial updates is like just updating the player instead of the entire screen. You just move that special zone and update only the area around it. And then you can also use another trick that can be done on the Speccy, which is colors for draw effect. This is a name I came up with, but it's a very simple thing that I can explain. We basically can draw the entire screen full of these bubbles, and then if we put colors on the paper, so Spectrum has 2 colors, which is called paper and ink, in 8 by 8 block, so you can only have 2 colors. And here if we change the colors, you will see there is a special one that is apparently all black, doesn't look like a ball or a bubble anymore, because the paper and the ink are the same, okay? So if the paper and the ink are the same, what happens? The bubbles actually disappear, right? Or they are not there anymore. What does this allow us to do is to actually make a screen with some cleanup of the graphics, put some more colors, and then we have some highlighting, And then we have a screen that we can use as a game by mixing all this. And then actually having a background that looks, there is a background, but everything is actually not being drawn. We are just changing the colors. Okay, this is a trick so that we can get close and fast enough to a 50 Hz games with a data that is a bit large for the game we want to do as fast as we can. So going back to the challenge regarding graphics, so we have on the left side the arcade and the Spectrum on the right. Although this seems like a smaller screen on the Spectrum, we are seeing also the border. So the resolution is slightly higher on the arcade. So we have 320 on width that we'll have to cut somehow to 256. And you will see the changes because the screen of the Spectrum is only the area that is now marked in light white. So these are some experiments that I did to make sure that we could represent the same images from the arcade on the Spectrum. In this case, we are, for example, gluing the data to the border so that we can use the border as a frame, so that makes the screen look bigger. Okay, so trying to improve our reduced resolution. We can also test some graphics and see if they are portable to the Speccy and look similar, and apparently it's possible. And then we can also try to mimic the playing screen, and here we can see that the columns were made very thin on the Spectrum because the gameplay area is more important than the frame around it. So this is the one-player version, and this is the two-player version. Obviously, we won't be able to do the background graphics of the characters that the arcade has, because it's really not possible because of the trick we are using and the lack of bandwidth for animating it. So here are some more graphics. This is actually from Magical Drop 3 that was supposed to also be supported in the future. And these are some examples of how those graphics eventually can look on the Speccy, and I would say they are reasonably close. So the challenge is to make a port, but the port implies you have access to the original source code. That's why you're porting, right? But usually, when you have a port, there is no uncertainty. Every doubt you can look at the code and just check it and implement it some other way if needed, but you have no doubts. Just look at the code. But when we are actually doing a port, most of the time we are doing reverse engineering. So we are looking at something working, we don't have access to the code, or at most we have access to the assembly and we need to disassemble it. Okay? So reverse engineering can be a real pain because we either don't have the code, or we don't have the assembly, or we don't have the details of gameplay features and stuff like that, which makes it very complex to determine complex behaviors like power-ups and combos and stuff like that. A good trick is, for example, to film the game and then stop frame by frame. You can do this in Google, for example, on YouTube. And this will allow you to gather some of the very important tips how that was implemented. So, gameplay, as I showed before, is a match 3 basic game. So 3 colors and then pop. There is an animation. Actually, the animation is not playing. I'm not sure why. So let me go back. This was an explanation of the game. Maybe I can go back and just show you. I think there is a... Okay. Okay, so that's basic gameplay. So match 3 basics. Then we have a global power up that blows up everything that is of the same color, and ice balloons actually don't blow up themselves. They need to have some other part match nice right next to them, and then they will blow up also. So it's basic gameplay because this was for arcades and they want your coins. Basically, you need to spend coins to actually learn the extra features of the game, like power-ups, combos, attack patterns, and all that. So the game has these many characters. There is a special move that you can do on the arcade that will give you 3 more characters to play if you know how to do it. If someone in the audience then wants to know, I can teach you. It's the 3 players that you play against when you are playing against the computer, and they only come up in the higher levels. So these players have this status like power and a special balloon, item balloon. This item balloon is actually the definition of which power-ups you'll get on which colors. So if you choose the chariot, for example, the 3rd item, you will have only the power-up on yellow balloons, okay? Not on the others. So you need to account for that for your strategy. So after a lot of playing, I discovered that these are the attack patterns for each of the players. So this is not something I saw in the code, it's something we had to play and check what are they doing on each time we attack with one of these players. So this pattern is 8 by 7 and it repeats after this block. It's different for each player, and one of the players, which is rightly named Fool, is the one that is easiest to actually beat, but it's one of the funniest players to play with someone that actually plays really good, as long as you play really good also. You can finish a game against another player like in 30 seconds. It's really fast. So, compromises. As you can see, there are different colors when you play in the arcade, depending if you are on the right side or on the left side when you're playing against another player. On the Specky, we can't do that because we are not showing the players, although we can show the players at the beginning before we start, so we avoid the animations. So, from using color draw effect to be faster, what actually do we gain by doing this? So if we have 256 pixels horizontally divided by 8 because with a byte you define 8 pixels, and you do this amount, that's the amount of bytes you have to transfer, right? And this is the amount of bytes you have to transfer for colors. And the boost that we have is like 9 times because we are not doing the part of the pixels because they are mostly static except the player that will go back and forth, and we only will be updating the bytes. So that's a 9 times boost in terms of 9 times less work to do. So this allows CPU time for logic and gameplay. Okay, for a game like this, what do you think should be the data structure for a game board like this? Anyone? An array, yep. So when we have an array, should the orientation be XY or YX? And why? Why was a question. So as you saw, most of the game is vertical, right? So it will be a boost to actually access consecutive places if they are aligned. So YX should be the best orientation. So these are the regions, there are vertical animation, and because we also want to do color match search. What does this mean? When you need to do a pop, you need to search the board so that if you have a color match, like the 3 first are the same color, you need to then find every other color or any other balloon that is connected that should pop at the same time. And that can be a complex pattern to search, so it should be as easy as possible in the array. So if we clean this up, we will have something like this. So this is our array. And imagine we just place a new ball in that position, or we start searching in that position. So we'll search up first, then we continue searching up if the color matches, and then, as you can see, we'll have an algorithm that is something like mark and sweep. So if the position matches, we recursively call mark and sweep for top, left, right, and bottom, right? And there is a problem when we have these corner cases. So the middle one is easy, but the corner cases have a problem. Which is it? We need to check if we are out of bounds, right? So in a CPU that is very low on megahertz, doing more operations per tile or per item will be slow. So there is a workaround it. And the workaround is these operations are a problem that we want to avoid. So what we can do, and actually the image is gone. Nice. I'll go back and show it anyway. So what you can do is, instead of having this array that matches exactly the game board, we should have an array that is larger than the game board. So this allows for us to have accesses to the array without getting out of bounds. Because in a machine like this, an out of bounds usually terminates in a crash, because we'll surely write where we shouldn't be writing, and then it will overwrite some code or some data, and we'll get a crash. Okay, so what's wrong with this code? The problem is, if you look, we check a position and then we enter again the loop. And if the next check fails, we enter the loop, or we enter another function without actually needing to do it, right? So if we check first and enter later, we will actually be able to avoid that. So this is the case we want to avoid, right? The if valid. But we want to do the check and mark and sweep as soon as possible. So if we do something like this, it will be a lot less tests, right? Because we'll check before we go in, not after. Okay, so this is to avoid the edge cases. LibreOffice is very nice to us because a lot of animations disappeared. Okay, let's go. So what else can we do? We can do loop optimizations, because every time we do loop and roll, we will lose a lot of instructions that would actually take time, but will make us force the loop to actually have a multiple of the instructions that is inside. But that's actually useful to loop and roll. And then something that is maybe a sacrilege, but in the spec is very useful, is to have self-modifying code. I will not show assembly. I think it's too much for the audience in general. But the idea is, if you have an instruction that goes like load B, C, which is a register with a value from memory, that takes 20 T or clocks to actually run. But if that value is actually similar to a constant within the loop, we can actually overwrite the value of the memory in the instruction itself, and instead of loading from memory, we load BC with a specific value. And the difference is that that instruction, for example, will have 10T, which is half of the other one. Okay? So that will make it a lot faster, especially if we are within the inner loop that is very fast, or should be very fast. Okay, some animations are here still. And basically that's it. I won't explain the details of assembly because that's a little too much. So any questions? Questions? Oh, by the way, the game is available, and I can, if Yes, yes, I can show the game. So the source is available, and let me show the game then. Whoop. So the game is available on the Spectrum Computing website. You can search for Extruder, which is the name of the game. You can even play it online. There is some links here, and there is a video of it here. They have already loaded here. As you are from the demo scene, you'll probably recognize that effect on top. It was used by some Russian dudes that copied my code from the application or the game. So this is, let me show you, one-player game. So this is the Spectrum version, obviously, already updated. As you can see, you can see the actual bubbles go up and down because it's updating at 50 Hertz. We are actually interfacing the sound between the interrupts so that we can actually play sound and still update. There are some special parts, like you see the black one is the equivalent of the crystal or the ice balloon, so it doesn't pop by itself. And then if any other of the other ones actually highlights, that means that it's a special or a power-up. Why? Because we don't want to update the pixels, right? So I'm using just, you can see that on top now, a yellow one. Hopefully it's visible. That will mean that I'm not actually doing any updates to the pixels, and I'm just updating a color in an animation cycle that will allow me to avoid extra CPU, and I'm just updating the player on the bottom, which is the only thing that actually needs proper animation. Eventually, if there are not too many power-ups, we could update just a few on screen, but that means I would have to actually track them down and implement that code, which was not done. So this was the easiest way. Any questions? If not, I'll give this as presented. Hope you liked it. Thank you. And if you want, you can actually go to the website. Sorry. If you search Spectrum Computing for my name, you can find other games if this works. I'm not sure if I have network right now, but you just search and it should find all of the games for the Spectrum. I think I don't have a network or it's not working right. Or maybe it's here. Nope. Anyway, you can search for it and you'll find it. Thank you very much.